Hey everyone, and welcome back for another deep dive. Today we're going to be tackling something that might sound a little bit unusual at first, soft matter. But trust me, this stuff is all around you, and it plays a surprisingly big role in how our world works, and in some pretty unexpected places too. What's really cool about this one is that the source material you sent over is actually a book proposal. So we're basically getting a sneak peek into some cutting-edge research here before it even hits the shelves.
It is a fascinating proposal, laying out a vision for understanding soft matter, not just as a scientific field, but as a lens through which we can view everything from ancient history to the mysteries of the cosmos.
Okay, so let's unpack this a little bit. What exactly are we talking about when we say soft matter? It's not a term you hear every day.
You're right, it's not as familiar as solids or liquids, but it's just as fundamental. Think of it this way. Traditional solids have a fixed structure. Their molecules are locked in place. Liquids flow freely. Their molecules are constantly moving around. Soft matter lies in between. It can flow and change shape like a liquid, but still holds some internal structure.
So it's kind of like a hybrid state of matter.
Exactly. And that in-between nature is what makes it so fascinating and so useful. The proposal highlights just how wide-ranging this field is. We'll be looking at how ancient civilizations unknowingly mastered soft matter techniques, how it plays a crucial role in the Earth's geology and even the carbon cycle. And then we'll zoom out to consider its potential presence in the vastness of space, maybe even in dark matter.
Wow, I'm already intrigued. But before we get too far ahead of ourselves, let's go back to basics for just a minute. Can you give us a concrete example of soft matter, something we can all picture?
Sure. Think about bread dough. You can knead it and shape it. It holds together. Or look at clouds. They're constantly changing form, flowing and swirling, but they remain distinct from the surrounding air. These are examples of soft matter in action.
That makes sense. So it's not just about what something is made of, it's about how those components interact with each other to create these unique properties.
Precisely. And this proposal dives deep into those interactions, exploring how the arrangement and movement of molecules at a microscopic level dictate the behavior of soft matter on a larger scale.
And this brings us to the historical perspective, which is where this proposal really gets interesting. We're not just talking about lab experiments here. We're talking about how humans have been interacting with soft matter for millennia, often without even realizing it.
It's a journey through time, showing how different cultures have unknowingly mastered soft matter techniques. Take the ancient Egyptians and their incredible linen production. They understood how to process flax fibers, spin them into yarn, and weave them into durable and beautiful fabrics. This wasn't just about clothing. Linen had symbolic and ritualistic significance in their culture as well. They used it for wrapping mummies, sails on their ships, even for creating papyrus, which is a type of paper essential for record keeping.
It's amazing to think that they achieved such mastery without the scientific tools we have today. It was all about observation, experimentation, and passing down knowledge through generations.
And then we have the Chinese and their expertise in silk production. Silk was not just a luxurious fabric. It was a symbol of power and cultural exchange. The Silk Road, as it was known, facilitated the spread of silk and the knowledge of its production across vast distances, shaping trade routes, cultural interactions, even warfare.
So we're seeing how soft matter has actually shaped history in some pretty profound ways, impacting everything from fashion and trade to technology and cultural exchange.
Absolutely. And these ancient examples highlight a key theme that runs throughout this book proposal: the ingenuity and adaptability of humans in harnessing the properties of these materials, even without a deep scientific understanding of what was happening at a molecular level.
It's like they were intuitively tapping into the science of soft matter centuries before it became a formalized field of study.
Exactly. And this intuitive understanding continued to evolve through the medieval period. While there was still a strong element of mysticism and superstition surrounding soft matter, we start to see a shift towards a more empirical and analytical approach with the advent of the scientific revolution.
So we're talking about the birth of modern science, figures like Galileo and Newton challenging long-held beliefs, and emphasizing observation and experimentation. How did this new way of thinking impact our understanding of soft matter?
It was a fundamental shift. Instead of attributing the properties of soft matter to magic or supernatural forces, scientists began to seek explanations based on natural laws and principles. This laid the groundwork for the development of modern chemistry and physics, which would eventually lead to the formalization of soft matter as a distinct field of study.
So we've gone from ancient civilizations to the scientific revolution, tracing this thread of human interaction with soft matter through the ages. But where does this journey take us next? When does soft matter really step into the scientific spotlight?
Let's fast forward to the 20th century, a period marked by rapid advancements in science and technology. This is where soft matter physics emerges as a distinct field, building on the foundations laid by earlier pioneers.
And this is where things get really exciting, right? We're starting to unlock the secrets of soft matter at a molecular level, leading to incredible innovations.
Absolutely. One of the key breakthroughs of this era was the understanding of liquid crystals. These materials exhibit properties of both liquids and solids, and they revolutionized display technology. Liquid crystal displays, or LCDs as we call them, are now found in everything from smartphones to televisions, all thanks to the unique optical properties of these soft matter systems.
It's incredible to think that something as ubiquitous as our phone screens is based on this intricate dance of molecules.
And the exploration of soft matter continues to push the boundaries of science and technology. Nanotechnology, for example, allows us to manipulate matter at the atomic and molecular level, opening up exciting possibilities for creating new materials with unprecedented properties.
Nanotechnology is mind-blowing. We're talking about building things atom by atom, creating materials that are stronger, lighter, more versatile than anything we've ever seen before. And a lot of this research is inspired by nature, right?
You're exactly right. Biomimicry, the practice of emulating nature's designs and processes, is a key driver in soft matter innovation. Scientists are studying biological systems, like spider silk or gecko feet, to create new materials with amazing properties, from self-healing materials to flexible electronics, and even biocompatible implants that can integrate seamlessly with the human body.
It's like we're learning to speak nature's language at a molecular level. We've covered a lot of ground here, from ancient linen to cutting-edge nanotechnology. But it sounds like we're just scratching the surface of that soft matter has to offer. Where do we go from here?
You're absolutely right. We've only just begun to explore the vast landscape of soft matter. And one of the most fascinating aspects of this field is its relevance to our everyday lives. We've touched on its historical significance and its role in cutting-edge technologies, but now let's bring it closer to home. Literally.
I am all for that. You've got me curious. Where does soft matter fit into our daily routines?
Well, let's start in the kitchen. Cooking is essentially a form of soft matter manipulation. The textures we love in our food, from the airy crumb of a cake to the satisfying chew of a perfectly cooked steak, are all thanks to the intricate interplay of soft matter.
You know what? You're right. We often focus on the taste of food, but the texture plays a huge role in our overall enjoyment.
Exactly. And understanding how soft matter behaves during cooking can help us achieve those desired textures.
Right.
Think about making yogurt, for example. The bacteria in yogurt cultures convert lactose into lactic acid, which causes the milk proteins to denature and form a gel-like structure. That's what gives yogurt its creamy texture.
So we're not just mixing ingredients, we're actually manipulating the structure of food at a molecular level. It's like microscopic engineering.
Precisely. And it gets even more fascinating when we consider the chemical reactions involved in cooking. Take the Maillard reaction, for example. This reaction occurs when amino acids and sugars are heated together, and it's responsible for the browning of meat, the crust of bread, and that delicious aroma of roasted coffee.
Ah, the Maillard reaction, the one that makes everything smell so good. But it's not just about aroma, right? It actually creates new flavor compounds.
Exactly. The Maillard reaction is a complex chemical dance between amino acids and sugars, resulting in the formation of hundreds of different flavor molecules. These molecules give cooked food its complex and savory taste, transforming the sensory experience entirely.
So every time we sear a steak or bake a loaf of bread, we're essentially orchestrating a symphony of chemical reactions, all thanks to the magic of soft matter.
Precisely. And it's not just about home cooking. The field of molecular gastronomy has taken the culinary world by storm, using science and technology to explore new possibilities in cooking.
It's like food meets science fiction. We're talking about foams, gels, spheres, all sorts of mind-bending creations that push the boundaries of what we consider food.
Exactly. Chefs are using techniques like spherification, where they encapsulate liquids in thin, edible membranes, creating caviar-like bursts of flavor. Or they use hydrocolloids, like agar-agar or xanthan to create gels with specific textures and consistencies, allowing them to play with the structure and presentation of food in entirely new ways.
It's incredible how chefs are harnessing the properties of soft matter to create these culinary masterpieces. It's art and science working together in perfect harmony.
And it's not just about fancy restaurants and Michelin-starred chefs. Understanding soft matter can help us become better cooks at home, knowing how different ingredients behave under heat, how to adjust cooking times and temperatures to achieve the desired texture. These are all soft matter principles in action.
That's so true. Cooking doesn't have to be intimidating. It's about experimentation and having fun and maybe a little bit of science sprinkled in. Who knows? Maybe we'll discover the next big culinary innovation right in our own kitchens.
You never know. Now let's move from the kitchen to the bathroom, shall we?
Yeah.
Soft matter plays a starring role in the world of cosmetics as well.
Okay, this is where I get really interested. I have to admit, I'm a bit of a skincare junkie, and I'm always fascinated by the science behind those miracle creams and serums.
Well, then get ready for a deep dive into the world of cosmetic chemistry, where soft matter truly reigns supreme.
Bring it on! I'm ready to unlock the secrets of a flawless complexion.
One of the key properties of soft matter in cosmetics is its ability to form films and emulsions. These films and emulsions create a barrier on the skin, helping to retain moisture and protect it from environmental damage.
So that's how moisturizers work. They're essentially creating a tiny shield on our skin to keep it hydrated and healthy.
Precisely. And the type of soft matter used in a moisturizer will determine its texture and how it feels on the skin. For example, a moisturizer designed for oily skin might use a lighter emulsion, while a heavier cream would be more suitable for dry skin.
That makes sense. It's all about tailoring the product to the specific needs of the skin. And what about makeup? How does soft matter come into play there?
Think about the smooth application of foundation, or the way mascara coats and lengthens lashes. These effects are all achieved through the clever manipulation of soft matter. Pigments, oils, waxes, all these ingredients interact to create the textures and effects we desire in makeup.
It's amazing how these products can transform our appearance, and it's all thanks to the science of soft matter. It's like having a mini chemistry lab right in your makeup bag.
You could say that. And the innovation in this field is constant. New polymers and silicones are being developed all the time, leading to products that feel lighter, last longer, and provide better coverage.
It's like the quest for the perfect foundation or the ultimate mascara is an ongoing scientific endeavor.
In a way it is, but it's not just about performance. The sensory experience plays a huge role in cosmetics as well. The feel of a luxurious face cream or the subtle scent of a perfume. These are all carefully crafted using soft matter science.
It's true. We don't just want our cosmetics to work. We want them to feel good, to smell good, to be a part of a pleasurable and pampering experience.
Exactly. It's about creating products that not only perform well, but also appeal to our senses, making the beauty routine a more enjoyable and even luxurious experience.
We've come a long way from ancient linen and silk to modern cosmetics and molecular gastronomy. It's incredible to see how soft matter connects these seemingly disparate aspects of our lives.
It really is. And the beauty of this book proposal is that it highlights those connections, showing how soft matter is a unifying thread running through history, science, technology, and even our everyday routines. But the exploration doesn't stop there. The proposal goes on to delve into the role of soft matter in the Earth's geology, and even beyond in the vastness of space.
Now that's what I call a deep dive. I'm ready to journey to the center of the Earth and beyond. Okay, so we've explored soft matter in our kitchens and bathrooms. Where do we find it shaping the world on a much grander scale?
Well, get ready for a journey to the center of the Earth, because beneath our feet, soft matter is playing a crucial role in the dynamic processes that shape our planet.
Okay, I'm listening. What's happening down there?
Imagine the Earth's mantle, the layer beneath the crust. It's not a solid mass of rock, as you might think. Instead, it behaves like an incredibly viscous fluid, with soft matter flowing on geological timescales. And this flow drives plate tectonics, the movement of the Earth's massive crustal plates.
Wait, so you're telling me that the ground we're walking on is actually shifting and moving because of soft matter?
Exactly. It's this slow, relentless flow that creates mountains, causes earthquakes, and triggers volcanic eruptions. Think of the Himalayas, for example. Those majestic peaks are a result of the Indian plate colliding with the Eurasian plate, a process driven by the flow of soft matter in the mantle.
That's incredible. You know, we usually think of mountains as these static, unchanging features of the landscape, but they're actually a product of this dynamic, ongoing process deep within the Earth.
And it's not just about shaping the Earth's surface. Soft matter in the mantle also plays a crucial role in the carbon cycle, the movement of carbon between the Earth's atmosphere, oceans, and rocks. Recent research suggests that the Earth's mantle might hold more carbon than all the oceans in the biosphere combined.
Wow, that's a massive amount of carbon. What are the implications of that?
Well, it's kind of a game changer for our understanding of climate change. Studying the behavior of soft matter in the mantle could provide new insights into how carbon is stored and released over geological timescales, helping us better predict and potentially even mitigate the effects of climate change.
So the study of soft matter isn't just about cool new technologies, it's also crucial for understanding the very planet we live on.
Exactly. But the exploration doesn't stop there. The book proposal takes us even further, beyond the confines of our planet, into the vastness of space.
Now we're really going deep. Tell me more.
Think about interstellar dust clouds, those vast swirling clouds of gas and dust scattered throughout space. They're often composed of soft matter particles, tiny grains of ice, silicates, and even organic molecules.
So we're talking about the building blocks of stars and planets here.
Exactly. These dust clouds play a crucial role in star formation, acting as nurseries where new stars are born. Gravity pulls the dust and gas together, forming dense clumps that eventually ignite into blazing stars. And the composition of these clouds, the types of soft matter present, can influence the composition of planetary atmospheres, potentially even impacting the habitability of planets.
So the study of soft matter could help us understand the origins of planets, and even life itself, not just here on Earth, but potentially throughout the universe.
It's a really tantalizing possibility, and it gets even more intriguing when we consider dark matter. One of the biggest mysteries in astrophysics. We know it exists, we can observe its gravitational effects on galaxies, but we still don't know what it's made of. Some scientists speculate that dark matter could be composed of exotic particles, while others suggest it might be a form of soft matter, a vast network of cosmic filaments, or even hypothetical particles called axions that behave like a superfluid.
Wow. Oh, okay, hold on. So we could be swimming in a sea of soft matter, dark matter, without even realizing it.
It's a fascinating idea, and one that's being actively explored by researchers. It just goes to show how the study of soft matter can lead us down some truly unexpected and mind-bending paths, from the everyday to the cosmic.
Absolutely. Well, we've covered a lot of ground in this deep dive, from ancient civilizations to the Earth's mantle and the mysteries of dark matter. What would you say is the key takeaway here? What makes soft matter so important?
I think the most important takeaway is that soft matter is not just a scientific curiosity. It's a fundamental aspect of our world, shaping everything from the ground we walk on to the stars in the sky. And it's a field that's constantly evolving, pushing the boundaries of our understanding, and opening up new possibilities for innovation and exploration.
It's true. Soft matter is often hidden in plain sight, but it's a powerful force driving processes on scales both large and small. It's the stuff of life,
Yeah.
of planets, of the universe itself. Thank you so much for taking us on this incredible journey into the world of soft matter. I know I learned a lot today, and I hope you did too. And to all of you listening out there, we hope you enjoyed the deep dive and that you come away with a new appreciation for this fascinating and ubiquitous form of matter.